Okay, solving logarithmic and exponential equations. We'll just get started, and along the way we'll hopefully see all the rules and all the little things that we need to be familiar with. Bases are the same. We should be able to solve this then. This 2 is in the way in the sense that it should be over here with the x. Okay, we can do that because multiplying here means that it could have been an exponent on top of the x. Now these are the same in terms of log 3, log 3. So 4 is equal to x squared. That means that x is equal to plus or minus 2. Keep in mind that logs have domains, and so for the domain x had to be greater than 0. So my final answer is going to be x is 2. Same thing over here, or same thing, same idea here. We have same basis, so we can do a little math with that. So we would get x plus 2 times 1 minus x is equal to 1 here. Use the definition of a log. 2 to the exponent of 1, which is just 2, is equal to x plus 2 times 1 minus x. Let's distribute on this side. So what's that? X minus x squared plus 2 minus 2x. Those cancel. So that means that we get 0 is a negative x squared minus x, or 0 is equal to x squared plus x. That's factorable. Should have had a little more room there. That's x plus 1, so either x is 0 or x is a negative 1. Let's see what the domains say. So if x plus 2 has to be larger than 0, x has to be larger than a negative 2. Both of these are. And here 1 minus x needed to be larger than 0. So that means that 1 was larger than x. Excuse me. Or x is less than 1, and both of these are less than 1. So we actually have two solutions here. Okay, next one. So same start. These two could be put under the same natural log. So x times x minus 1. And that means that if the left side equals the right side, then x times x minus 1 has to equal x plus 2. Distribute. Bring this over here. That looks factorable, but it's not. So that means x is equal to negative b, so that's 2 plus or minus the square root of 4 minus 4 times 1 times a negative 2, all divided by 2 times 1. That's 2 plus or minus the square root of 8 with the negative canceling. That's 12 divided by 2. That's it. 2 square root of 3. So all the 2's cancel. So 1 plus or minus the square root of 3. So right now, two answers, but you have to check all three of these. So what does it say? X minus 1 is larger than 0, so x needs to be larger than 1. So 1 minus the square root of 3 does not work. So right now I'm thinking 1 plus the square root of 3. Let's check here. That means just x greater than 0 and x plus 2 is greater than 0. That only occurs when x is greater than a negative 2. So yes, we get one answer. So this is the right answer. Okay, so now solve exponentials. You can sort of do this two ways. Depends on if you want the calculator answer or not. If it doesn't say get an approximation, which means you would have to use a calculator, then you would take the log base 3 here. The log 3 on both sides will give you a nice clean answer because this bases are the same, so you just get the x. So you would get the log 3 of 7. If you didn't have a calculator, you can take the natural log on both sides. And we saw this a little bit in the previous section, similar to this. Then the x comes out to the front. The natural log does not disappear. But that would allow you, basically this is the change of base approach. That would allow you to rewrite this, and so you get x equals whatever that equals. And I'm going to cheat, and I did that on the calculator a while back. So that would be 1.77 if it told you to give a calculator approximation. So two answers. This is the more accurate answer, because it is exactly log 3 of 7. So, okay, so keep that in mind. So a lot of these, I think, I'll try to solve them both ways if I can, and then we'll move on and see what happens. So, alright. 5 needs to be over here so that I'm isolating my variable. So that's 3 over 5. So if I do not want to use a calculator, I would do this on both sides, the log 2 of 3 over 5. So this would completely cancel itself out. So, and on this side you would write that probably as the log base 2 of 3 minus the log 2 of 5. So that would be an answer that you could leave. If you wanted a calculator answer here, then you would you'd still do the first step. You divide by 5 on both sides to isolate it, and then you would say, well, let's take the natural log on both sides. So that means that you would get x ln 2 here, and then you divide by ln 2. And you would still split that up into an ln 3 minus an ln 5, so the same order as you did here. And now we're dividing by the natural log of 2. And that would allow you to give you a calculator approximation, and the calculator approximation here would be a negative 0.737. Okay, different bases, so I can't just equate exponents. So take the natural log on both sides. You could take the common log as well, by the way. The natural log is less writing. So you would have x minus 1 as an exponent come out, and 2x plus 3 as an exponent coming out over here. Now you need to get all things with an x on one side, so that means you're going to distribute first. So it's x ln 2 minus 1 times ln 2, that's just ln 2. And then here it's 2x ln 5 plus 3 times the ln 5. So this one needs to go to that side, and this one needs to go over here. So I get x ln 2 minus 2 times x ln 5 equals 3 ln 5 plus ln 2. The x's are common here and here. That means you can factor. Take out 1x, that leaves you with ln 2, minus the x is gone, so it leaves it 2 ln 5. And then you are left with one step. That is that to find x, you would then divide by this mess on both sides. And so I'm a little bit lazy. I want to write that twice. I'm just going to write down what the answer should be. And then again, if the problem said, estimate or give an approximation, you would plug this in your calculator and you get a negative 2.186. And so you do have to be able to do both. So you might want to check make sure that if you can get this as sort of the accurate answer, so make sure that if you can get this part, which is great, can you also get this part? Sometimes we're not sure how to use the calculator. Alright, then the last one, sort of a disguised problem here. The first thing that you need to look at here is that the 9 and the 3 have something in common, and that's a base 3. So you could write 9 as 3 squared, and that would make that a 3 times 2x, or a 3 to the power of 2x. And then this is actually reminds me of a trinomial, like, an x squared minus 3x minus 6 equals 0 type of deal. Well, that's really what you have here, except you have a 3 to the x that's being squared, minus 1 times a 3 to the x minus 6 equals 0. So that's factorable. Okay, if you're not really sure and you don't really see it, let's just say that 3 to the x is p. You can write this as a p squared minus a 1 times p minus 6 is 0. That would be p minus 3 times p plus 2 equals 0. And then you can solve that, and you could say either p minus 3 is 0 or p plus 2 equals 0. Keep in mind that p was 3 to the power of x. So 3 to the power of x minus 3 is 0, or 3 to the power of x plus 2 is equal to 0. Move the 3 across. since there's a 1 there, you get x equals 1 as an answer over here. And on this one, you move the 2 to the other side and you get a negative 2. And there's no number that you can put on 3 as an exponent to make it come out as a negative. Keep in mind, exponential functions, like the graph of that, would always be above the x-axis. So there's no number you can plug in here to make it come out as a negative 2. So that doesn't have any answers. So finally, you could say x equals 1 is your only answer. Okay? Thanks.